Welcome to ScaleUp University. Welcome to the course on building applications with AI agents. So this is the lecture 2 of module 2, and in this lecture we will be discussing decomposing tasks for agent design. So let us look at the lecture overview, like what this lecture is about: decomposing task for agent design. So see, most beginners, they try to write prompts, call an LLM, add tools, and hope it works. So, so basically, this creates a black box where failures are hard to debug because you don't know if the model failed at understanding the goal, searching for data, or synthesizing the answer. Because see, the idea is that, like, when we are designing the agent, the beginners, what they do is that they know that, okay, an agent has to achieve a goal, so they will come up with a workflow. So what they do is they straight away just write the prompts, give it to LLM, and add some tools so that LLMs can call those tools, and then they hope that, okay, they have built an agent which can perform some actions which will solve a problem. Now this approach, it might solve a problem, like it might like help you in achieving the goal. It might bring certain level of autonomy or like autonomous, but the problem is this, like it is like a black box which we are creating where it is very hard to debug the flow. Because here it because here we are not at all monitoring the flow. We don't know if the model failed at understanding the goal, searching for data, or synthesizing the answer. So beginners approach, it's not that good. So how the professionals, they design the agent? So if we talk about the professional approach, so what they do is that they straight away decompose the problem. So they decompose the problem first. So agents are not built from prompts. They are built from structured task decomposition. So that is what this lecture is about. So the idea is very clear that, okay, when you are trying to design an agent, whatever problem you are trying to solve, you don't have to write prompts for that. Rather, you have to decompose the problems into subtasks. So let us suppose we have a complex workflow. So we have to decompose it into tasks. Like to achieve this complex workflow, we have to accomplish task A followed by task B, task C, like that. Now, this is the right way because here, by decomposing the workflow, you can insert validation gates between steps. If step 1, for example, search, fails, the agent stops and retries rather than hallucinating in step 4. Now, here, the debugging is very easy and the system will by default become resilient. Any task fails, will not go forward, will retry until that task is success. So that's the power of decomposing the problem. So basically, we are essentially building a flow chart where the LLM only handles the logic of each small node, which is a task. So now the LLM, it's not at all looking at the complex workflow. Rather, the LLM, it is been given the small task, and it is only concerned about solving those tasks. And this makes overall system predictable because if something is wrong, we can get an idea that, okay, task A failed, task B failed, or task C failed, and that is the root cause of the problem. And if we are able to analyze the root cause, we can very easily debug, solve the problem. So this is the professional approach, and this is what we will be studying in this lecture. So now it's very clear that, okay, if we are planning to design agents, first, you decompose the complex workflow into task. So that's the idea. So that is what we should do. Like when we are designing agents, we have to do the structured task decomposition, not just prompts. And then for each task, we can design prompts. We can give it to the LLM. so that LLMs can take care of or solve each task. So the idea is that if you are not able to, like, if you're not breaking the complex workflow into tasks, then you cannot build agents reliably. So if we want to build reliable agents, then we have to decompose the problem into tasks. And that is what this lecture is about, wherein we will learn how to decompose tasks for agent design. So this lecture is about sh- like here it's because we already understand agents. Module 1 is all about understanding agents. We already understand agents, but now this lecture is designing agents correctly, because module 2 is all about designing agents, and this lecture will help you in designing agents in a correct way, in a professional way. So that is what this lecture is about. So if we look at the topics that we will cover in this lecture, so we'll talk about mapping real world workflows to agent actions, identifying structured versus unstructured inputs, translating business APIs into agent tools, designing tools around capabilities, not endpoints, determining scope boundaries, when to keep the problem narrow, avoiding over automation early, from chatbot to decision plus execution system, architectural insight, the three-layer pattern. And finally, we will conclude this lecture by discussing practical design checklist. So all these topics we will cover in this lecture itself, one by one. So this is the module 2, designing agent systems, lecture 2, decomposing tasks for agent design. And we will be starting with the first topic of this lecture, mapping real world workflows to agent actions. So now we will learn how to map real world workflows to agent actions. So see, every agent system, it begins as a human workflow. Let us look at an example to get more clarity on it. If we talk about e-commerce support, if we talk about e-commerce support example, the human workflow is something like this. That the human agent, what he will do is he will read customer messages, he will read the customer message, he will interpret the request, he will look up the order, he will decide action, he can call backend API and send confirmation. So this is the human workflow. So now the idea is very clear that whenever we are trying to design an agent, so the human workflow first, we should analyze it. We should look into the human workflow, and then we should ask some important questions, that in this human workflow, which steps are cognitive, which steps are deterministic, which steps are structured and judgment heavy. So we have to ask which steps are cognitive, which steps are deterministic, which steps are structured, and which steps are judgment heavy. And then we should go for designing agent. So agent design is basically the mapping. So agent design, it requires mapping. Like we have to map the human steps with agent capability. So we have to map the human workflow with the capabilities of agent. So we have to convert to agent workflow. So how we do it? So for human workflow, the starting step is read message. So for agent, it will be parse natural language. Then human, he will interpret the intent from the message. And for agent, it will be classify plus extract parameters from the message. For human, it is lookup order. For agent, it will be query API. For human, the work is decide action. For agent, it will be select tool. For human, it is like call API. For agent, it is execute tool. Like whatever the tool was selected, we have to execute it. And for human, it is send confirmation. For agent, the workflow will be generate response. So this is the mapping we are talking about. So now it's very clear that whenever we are trying to design an agent, so first we have to clearly articulate the workflow. We call it the real world workflow or human workflow. And then we have to look in that, okay, which steps are cognitive, which steps are deterministic, structured, judgment heavy. And based on that, we have to identify the tools which would be required by our agents. So we call it agent capability. And then we have to map. Every step you have to map. And this mapping, which we will be doing while designing the agent, it is the foundation of agent architecture. This mapping is the foundation of the agent architecture. Identifying structured versus unstructured inputs. If we talk about unstructured input, so what are unstructured inputs? If we look at the example, like the free text, email, chat messages, voice transcripts, documents, these are unstructured inputs. And what are structured input? If you look at the examples of structured input, order ID, account number, dates, status code, API parameters, these are structured inputs. Now, if we talk about agents, AI agents, they deal with both structured inputs as well as unstructured inputs. So agents operate at the boundary between structured and unstructured. And so the idea is that, see, when we are designing agents, agents should have the capability of converting the unstructured input into structured input. This is like very, very important. The capability of converting the unstructured input into structured. So that conversion is very critical. So how that conversion will be taking place? So agents, first they have to interpret the unstructured input. So the step one is to interpret unstructured input. Agents, they should interpret the unstructured input. So the model, they must extract intent. So this is very important. Whatever the unstructured input is there, we have to extract the intent. Intent is like a goal or what problem we are trying to solve. So intent will give us the problem, the goal. Extract entities. Entities means in that unstructured input that the information, like if it is a complaint, what the complaint is about, what is the order ID, who the person is involved. So that is entities. So we have to extract the intent. We have to extract the entities. We have to infer the missing context and we have to handle the ambiguity. So that is how we should interpret unstructured input. So now it's very clear that the agent, it should be able to interpret unstructured input, and what it will be doing is that it should extract the intent, extract entities, infer missing context, and handle ambiguity of unstructured input. If you look at an example for this, so if the text is, hey, the mug I bought last week broke, can I get my money back? Like let us suppose this is the unstructured input which the agent received. Now agent has to interpret this unstructured input, and how it will do, it has to extract the intent. So here the intent is refund, because the main goal or the main problem which needs to be solved is refund, because the customer wants refund. So intent is refund. And if we talk about entities, so mug is the entity, and definitely order ID or customer ID, that will also be entities. And the for timing context, if we talk about the context last week, so this is what is interpreting unstructured input is all about. Now the step two is, whatever information we extracted, we have to convert it into structured action. So what we did is, the agent, it received the unstructured input, it interpreted it, it extracted key information, and then it has to convert it into structured version. So based on the intent, if the intent is refund, the tool call should be issue refund. And based on the product mug, the agent should get the order ID, exactly the mug which the customer ordered, and the reason, damaged item. So we call it the structured action. structured version, structured version. So that is the conversion from unstructured to structured. And this is very important. And see, the idea is that large language models, they can understand the natural language. And hence, because of large language model, we can do this. We can convert unstructured input into structured input. And that is what we will be doing in our agent. When you are designing the agent, it will be exposed to the real world. It will be taking in unstructured input. We will be extracting the intent, extracting the entities, inferring the missing context, handling the ambiguity, and whatever information we extracted, we will convert it into a structured version. So here now it's very clear that we can say that the agents, they are like translation systems. They can translate the natural language into structured decision and then execute set of actions to accomplish the goal. So if you don't clearly separate structured and unstructured layers, your system becomes brittle. So this is very important. The conversion from unstructured to structured is very important. So we start with unstructured input, convert it into structured decisions, and we execute action. And with this, we'll accomplish the goal. And here the system will be very flexible. It will not be brittle. Translating business APIs into agent tools. Okay, this is also like very interesting and important. So the idea is that we have agents, and we know that agents, they can execute, they can act through tools, and these tools, they call business APIs. So this is the architecture basically. So agents, they never directly interact with business APIs. Rather, agents, they should interact with the tools. So agent will interact with the tools, and those tools in the background, they might call APIs, business APIs, because raw APIs are not agent friendly. So a very important learning for us, we should not like our agents, they should not directly call business APIs. Rather, they should call business API via tools. The reason for that is raw APIs are not agent friendly, the request and response. So the idea is that we should like wrap the business API, we should have tools, agent tool interface that should communicate with business APIs, and agents should directly call the tools and let the tools take care of the business APIs. So that is what is translating business APIs into agent tools means. So the idea is very clear that let us suppose we have written like hundreds of business APIs that we want to include in our agentic AI workflow. Now, our agents should not directly make use of those business APIs. Rather, we should translate those business APIs into agent tools. So we developed 100 APIs, that's very good. But now we should also build some tools. We can call it like agent tool interface. And those tools should be responsible for handling the business APIs, and agents are concerned only about interacting with the tool and not the business APIs. So that is the idea. Let us look at one example to get more clear understanding. So let us look at an example of a business API. So definitely API, we know that it's like a request and response. So it's like post request. The name of the API, the endpoint is refund. And these are the parameters it is taking, the order ID, the amount, and the reason. So this is like an example of a business API. Now, this business API, so our agent should not directly hit this business API. Rather, for this business API, we should translate this business API into an agent tool. So this is what the agent tool will look like. So what we will do is that we will make a tool called issue refund, and we will give a description that it will issue a refund for a given order. And the parameters it will take is order ID and reason. Now this agent tool, it's like an interface. It will call this business API in the background. And our agent, it is exposed to this tool. So our agent can call this tool. So when the agent will call this tool, it will just call this issue refund, the name of it. And when it will be called, business API will be hit. And that will be taken care by this agent tool. So that is the right way. So now it's very clear that, okay, we have to introduce new capabilities in our agentic AI application. We can make use of third-party APIs, or we can develop our own APIs. Now we should not expose the APIs directly to the agent. Rather, we should translate it into tools. So for APIs, we should design agent tools, and our agent should communicate with the tool, and tool will take care of the business APIs or the third-party APIs. So that's the idea. Now, what's the importance of this translation? So this translation is very important. See, model will choose the tool based on description, because every tool will have a description, and based on the description, the model, the LLM, will decide which tool to call. So that's why we should like write a very good description. So clarity is the key here, and clear schema, it will reduce hallucination. And because of this, a very good definition of agent tools, the good description, the parameters, the large language model, it will not get confused because of this clear schema. It will reduce the hallucination. Less guessing work will be there. Less guessing will be there. And proper abstraction, it improves reliability. Proper abstraction, it improves reliability. And see the now how it will improve the reliability, I'll tell you. See, the idea is that since agent is interacting with a API via a agent tool, what advantage you get is, let us suppose a third party API it's not working, some parameters got changed, or something happened to it, or some endpoint got changed. Now with a very clear design, like we know that, okay, this API is been dealt by this agent tool, so you just have to modify the agent tool a bit, and no need to change anything in your agentic app. It's like plug and play, because we want the tools to be plug and play. We want the tools to be plug and play. So the idea is very clear. We are developing an agentic AI application wherein we can have multiple agents. Now the tool layer should be very flexible. It should be plug and play. I can add whatever tools I want. I can remove whatever tools I want. And for that to happen, tool should be something which is independent. So that's why we have a concept of interface. Interface will just contain the information about the name of the tool, the description, and the parameters which it will take. And if and any changes you want to do, you just have to change the interface and something at the tool level. Like any API is not working, anything changed, any endpoint got changed, new parameters it want, you have to update the tool and not the agentic AI application. So that is what is very important and interesting. So that's why now it's very clear that we have to translate the business APIs into agent tools. Designing tools around capabilities, not endpoints. Okay. Now it is also a very important discussion we are making, wherein, see, the idea is that if for every endpoint we make tool, like if we try to create one tool per API endpoint, that is a very bad approach. So if we create one tool per API endpoint, it will be like a very cluttered, and it will create lots of confusion. So rather than creating one tool per API endpoint, the better approach is design tools around user intent. So the idea is that, see, based on the intent of the user, we should design the tools. Like, for example, in the e-commerce support, the intent might be to refund, or the intent might be manage user account. Now, this is one intent, manage a user account. Now, so we will create a tool for that, manage user account, and that tool can like contain several API endpoints. Like there can be an API endpoint for creating profile. There can be an API endpoint for updating info. So now it's very clear that when we are deciding the tools, so we have to design the tools around capabilities and not endpoints. So capabilities is the like the intent, like what user wants from that agent, or from that agentic AI application. So we should design tools around capabilities. For e-commerce, the end user might be interested in capabilities like manage user account, process order, and browse products. So we are making different tools. Like we are making one tool called manage a user account. We are making a tool called process orders. We are making a tool called browse products. Now every tool will contain relevant API endpoints, collection of endpoints. Like process orders, it's a tool. So agent will interact with this tool, process orders, and this tool will make use of API endpoints like place order, cancel order, update address. Similarly, browse products is a tool, it's a capability, and our agentic AI application can access, can interact with this tool. It can call this tool, and this tool will further be containing the API endpoints, relevant API endpoints, like find items and view details. So it is more of like a microservices kind of an architecture. It's more of like a microservices architecture wherein like we have a user service. So here user service is like a tool, order service is like a tool, and it will further contain API endpoints, relevant API endpoints. Product service is basically a tool. In agentic AI application, this product service will be a product tool which will have the capabilities of like finding the product, searching the product, and shipping service will be a shipping tool. So now it's very clear that okay, when we are building agentic AI application, whatever microservices which we have been designing in the traditional softwares, that microservices will be converted in the form of tools. So that's the idea. So the key learning or the key takeaway is that we should keep the agent tool layer intent driven, clean and simple. So whatever tools we are designing, we have to design it around capabilities. So it should be intent driven. Every tool should have a specific capability or a user intent. It should be clean and simple. Tools should match how humans think, not how backend engineers structure endpoints. So when we are designing the tools, we have to design in such a way that what capabilities that tool is adding or what problem we are trying to solve with that tool. So we have to think like the from the mindset of a human and not that of a backend engineer. So instead of like having update shipping address version 2, update shipping address version 3, like this is the endpoint, and for every endpoint if I am having a tool, that is very bad. Rather I should have one tool called update address for order, and that tool should take care of the API, like which API it wants to hit. That's the idea. Determining scope boundaries. So one very like a important insight. See, scope control is where most projects fail. And this is applicable for agent design also. So the idea is that when we are designing the agent, the scope should be very clear. The scope. So that is what is determining scope boundaries. So whenever we are designing an agent, we should answer this question. What is version 1 of the agent responsible for? What is version 1 of the agent responsible for? If we try to correlate it with the e-commerce example, so in the e-commerce example, the customer support agent which we are trying to build. So what is the scope of version 1 for that? Like the agent, it can cancel order, it can refund item, and it can update address. So it can do only these three things. So that is the scope. So now it's very clear that whenever we are designing an agent, it should be very clear that okay, in version 1 what should be the scope of it, in version 2 what should be the scope of it. And we might think about lots of functionality. So for version 1 the other functionality will be out of scope, that we can consider in subsequent versions. For example, fraud disputes, legal claims, policy exceptions, complex billing. So these are some advanced functionality which we can introduce later in subsequent versions. So that is the scope, determining the scope boundaries. So scope control is a strategic activity that ensures a project remains focused, stays within budget, and meets its original objective. That's the main uh, importance of scope control. So scope boundaries protect you from over complexity, because see, scope boundary now it prevents the agent from becoming a black box where failures are hard to debug because it is trying to do too much at once. So scope boundaries it protect you from over complexity. It protect you from edge case explosion. So it avoids the snowball effect where rare specialized scenarios like legal claims consume disproportionate development time. And that is very important. If the scope is very clear, we will not end up wasting time. Edge case explosion, we can avoid it. Scope boundaries, it protect you from premature optimization. It prevents spending resources on scaling or refining features that may not even be the core drivers of project success. So, scope boundaries means the most important features we should consider it first. So, it protects us from premature optimization. Like we might not end up wasting resources or time on something that is not important. And it also protects us from security risk. It limits the attack surface by restricting the sensitive data the agent can access or the high stakes action it can perform. Because now, since we are like fixing the scope boundary, we are also eliminating the security risk because some advanced features we will not at all think about that. And if it is not involved, automatically the security risk it is eliminated. So the key learning is when we are designing agents, the agents they should start small. Agents should start small and they should expand gradually. That's the idea. When to keep the problem narrow. See, you keep the problem narrow when you are validating the architecture. Because see, if the architecture is not clear, we have to keep the problem narrow. Keeping the problem narrow means it might be there that the problem might involve 10 things which we should consider. So instead of going for all those 10 things, we should start with only two things which we should try to solve. So that is the meaning of keeping the problem narrow. So we should keep the problem narrow when we are still validating the architecture of the agent. Like a narrow problem, it allows you to verify that your data flow, tool calling logic, and state management, it actually works without being distracted by complex business logic. You keep the problem narrow when you're testing reliability. So narrowing the scope, it will let you hit production grade benchmarks faster. We'll be able to test the reliability and learning failure modes. So keeping the problem narrow, it will also help us in learning the failure modes. Every LLM has blind spots. By focusing on a narrow slice, you can very quickly identify where the model hallucinates or misses instructions. And if you need quick ROI, you have to keep the problem narrow. So if we talk about narrow problems, they are easier to test. Like you can write unit tests for a narrow problem. Narrow problems are easier to debug. Very easily we can debug it. When a narrow agent breaks, you can pinpoint where the issue is, whether it is in the prompt, the tool, or the data. So narrow problems are very easy to debug because if anything goes wrong, we can debug, we can check whether the problem was in the prompt, it was in the tool, or it was in the data. Narrow problems are easier to explain. Narrow problems are easier to explain. So stakeholders and users, they trust what they understand. A tool that says I cancel orders is more trustworthy than one that says I am an AI assistant for everything. So narrow problems are easier to explain and narrow problems are easier to scale later. Because once you have a highly reliable address update module and a refund module, you can orchestrate them together into a larger system. So the idea is very clear that when we are designing the agent, we have to start with narrow problem. The problem might involve n number of things. We have to select 2 3 high priority things, accomplish that, and then that will be the version 1, that will be the scope. Then in the version 2 you can add more features and you can keep on evolving your agent. That should be the idea. Like for example, like if you are designing a e-commerce system, like an agentic AI application for e-commerce system. So you should, like if you're planning to design agents for e-commerce system, you can start with just a very basic agent which can cancel order. Like one agent which is entirely responsible for canceling order. Then you can add more features to that agent. And this small slice, it is intentional because if it is able to solve one problem, very we because in solving this one problem, we are validating the architecture, we are testing the reliability, which we are learning the failure modes also, and at the end we will have an agent which is accomplishing a task. So return on investment will get. Then we can keep on adding more and more features to it. So the foundation first. So that's the idea. Avoiding over automation early. So in designing agents for agentic AI application, over automation is a common mistake. So we see what happens now. Engineers, they get excited and they try to automate everything. So that's wrong. So over automation is like it's dangerous. It's a common mistake. And now what's the problem we might face with over automation? See, when an agent tries to handle every nuance of a human process, that's over automation, it stops being a tool and starts being a liability. Because see, with over automation, we will have complex decision trees. So you will end up having very complex decision trees. So as you add more if then logic to cover every edge case, the system becomes brittle. Increased failure risk. Every automated step is a potential point of failure. Every automated step is a potential point of failure. Reduced trust. Users and stakeholders, they lose faith in AI after one high profile mistake. Because see, with over automation, the chances of mistake increase failure risk, and if it makes mistakes, trust will be gone. If an agent automates a sensitive task incorrectly, humans will stop using it entirely, even for the parts that work perfectly. Because trust is the key. One mistake, the trust is lost and will not use that agent. Difficult debugging. This is obvious that when an autonomous system it makes a mistake in a massive interconnected web of tasks, finding the root cause is like looking for a needle in a haystack. It will be very difficult to debug. And harder evaluation. You cannot easily measure performance if the agent's output is a complex multi-stage transformation. Evaluation becomes subjective rather than data-driven. So now it's very clear that we should avoid over-automation early. We should start small and keep on evolving. So the better approach if we talk about is, so if we are planning to automate, we should automate repetitive tasks like high volume tasks that drain human energy. For example, data entry. Something which is repetitive, which is draining away human energy, high volume task that we should automate. We should automate rule bound tasks like processes with clear yes no logic and no gray areas. And we should automate reversible decisions which can be undone. like low stake actions that are easy to fix if the AI makes mistakes, like drafting a generic email. Now, drafting a generic email is something if the agent drafts a wrong email, it's okay, we can undo it. So now it's very clear that okay, when we are designing agents, what task we should automate is in the workflow, what task we should consider for automation, the repetitive task, the rule bound task, and reversible decisions. And what we should avoid automating, we should avoid automating, we should avoid high risk actions involving large sum of money or physical safety. So we should avoid automating high risk tasks, irreversible tasks which cannot be undone, tasks that cannot be undone, like deleting a database or sending a final legal notice. Policy sensitive tasks, like nuanced decisions that require interpretation of intent or spirit of the law. Their agents can make mistakes and we should avoid automating it. Let humans take care of high risk tasks, irreversible tasks, policy sensitive tasks, and emotionally complex tasks. Handling an angry customer or delivering sensitive news, let it be taken care by humans and not agents. So the key takeaway is agents should assist before they replace. So in repetitive rule bound and reversible decisions, agents can take over, but in high risk, irreversible, policy sensitive, and emotionally complex tasks, agents they should assist before they replace, wherein they should bring human in the loop. And if human, like they should take inputs from the human, try to solve the problem. If it is not able to solve, let it should hand over the problem to the human. Let human agent take care of the problem. So avoiding our over automation early, avoiding over automation early. That's the idea. From chatbot to decision plus execution system. If we talk about chatbot, a chatbot it generates responses. On the other hand, if we talk about agent, an agent, what it does is it makes decisions. It makes a plan and it executes that plan. It executes actions. Agent can call tools. It tracks progress. So the outcomes of the action, it can assess it. It can track the progress and it monitor the outcomes. So it tracks the progress that okay, 10 actions needs to be executed, 5 executed, 5 more remaining. So it will track the progress. It will monitor the outcome. So the key difference if we talk about a chatbot and an agent. So chatbot it responds, whereas agent it acts. Chatbot it will give you a strategy, but agent can act on that strategy. Chatbot is stateless, wherein every interaction will be new for it. It will not remember anything. But agent is stateful, wherein all the interactions it will keep on storing it in the form of a context memory. It will remember its previous actions, the outcomes of it, and it will keep on updating itself, revising the strategy. Chatbot is singleton. Singleton means okay, I will give it a query, it will respond it. Done. Singleton. Request response. But agent, it is like a process, it is like a loop wherein I give it a goal to accomplish and it will keep on working on it until the goal is achieved. So it follows something called like a loop. So it is multi-step. Agent is multi-step. Chatbot, it can only generate text only, no tools, nothing. But agent, it has access to integrated tools, wherein agents can call the tools, tool integrated. So the transformation happens when natural language, like from natural language, we go for tool selection, then executing those tools and confirmation. So see, chatbot is just about natural language. But now we are going one step ahead, wherein we are processing the natural language and then we are making a plan. And to execute that plan, we are selecting the tool, executing it, and checking whether we have achieved the goal. So that's what agent is. So that's the agent threshold. So from chatbot to decision plus execution system. So agent is about decision plus execution system, wherein the agent will decide the action plan. Okay, to accomplish this goal, these are the things which needs to be done. It will decide what tools should be called in what order. And once the planning is done, it will execute those tools and it will measure the outcome, assess the outcome. And until the goal is achieved, it will revise, it will re-strategize, and it will keep on doing it. The loop until the goal is achieved. Architectural insight, the three-layer pattern. So see, after decomposition, our agent will have three layers. So when we decompose the agent, we will have three layers. So the layer one will be the interpretation layer, which is responsible for interpreting the unstructured input. So model interprets user input and converts it into structured. So agent, we are decomposing it into three layers. The first layer is all about perception, receiving the unstructured input and interpret it. And how the model will interpret is it will extract the intent, the entities, the context, and ambiguity, and it will convert it into the structured version, structured input. Layer two is the decision, wherein the agent will make the plan, because when it interpreted the input, it knows the intent. It knows like, okay, what goal needs to be accomplished. It has the context and it has some entities also. So with that information, it will decide. It will decide a plan. It will decide the tools, the order. So that is a layer two. So system select tools or actions. So layer one is model interprets user input. Layer two is the decision layer. So model layer one is the interpretation layer. Layer two is the decision layer, wherein the system selects the actions, the order of actions and the tools. And layer three is the execution layer, wherein whatever the planning was done in the layer two, it will be executed. So tool will perform real world actions. So every serious agent will follow this pattern. If you blur these layers, you create fragility. So we have to separate these three layers very clearly. So now it's very clear that when we are designing agent, interpretation, that is perception, is something which should be independent. It is about converting the unstructured input into a structured version. Decision is something which should be independent. Once the structured input we feed it to the decision layer, it should make a plan, like the set of actions, the order of actions, and the tools needed to execute those actions. And layer three execution should be something which should be independent, separate. So if you separate them clearly, cleanly, what you will create is clarity. So that's the idea of the three-layer pattern for agent design. Practical design checklist. So now we'll discuss the practical design checklist. So the idea is that before building an agent, you should ask some important questions. And that is what the practical design checklist is. So you should ask, what human workflow am I mapping? So we should first have the human workflow or the real world workflow with us. What part is unstructured? What part is structured? What APIs are involved? So the idea is very clear. We have the real world workflow. Then what kind of structured input that workflow consists of? Then we should think about a way of converting that unstructured input into the structured input. Like we should interpret the unstructured input. Like we should extract the intent, entities, the context, and the ambiguities. And what part of it is structured? What APIs are involved? So based on that, we have to design the tools. What tools I need? So now we know that agents should not directly call the APIs, rather than whatever the capabilities the agent is looking to solve, or the capabilities the agent should have. For every capability, we should design a tool, and that tool should consist of APIs. So we should separate APIs with the LLM. So LLM will only be interacting with the tool, and tool will be hitting the APIs. And setting up the scope boundaries is very important. What is out of scope, that we should ask. What decisions should remain human controlled, that is over automation. We should avoid over automation. If something is sensitive, like irreversible task, or which involves some risky things, agent should not at all be dealing with that. So what decisions are sensitive, irreversible? So we should identify that. What decisions should remain human controlled? What actions are reversible, that we should identify, and agents should automate it. Agents should be, because if agents they make mistake also, since those tasks are reversible, humans can handle it. Like drafting an email is a reversible task, because if agent made a mistake in drafting an email, no problem, I can draft a new email. And success metrics is very important. What success metrics define completion? So now it's very clear that when we are designing an agent, we have to keep in mind that first we have to like prepare the real world workflow or the human workflow which we are trying to automate via agent. Then the structure, the unstructured input which are involved. Then we have to devise a way to convert that unstructured input into a structured input, extracting the entities, intent, context, ambiguities. Then, based on the capabilities, we have to design a tool for capability. Every capability, there will be a tool, and that tool will be using APIs. Then the scope. Okay, what should be the features in version 1, version 2, version 3? That is the scope. And we should avoid over automation. So we should decide that what, like in the workflow, what are the things which are reversible, which I can automate, and what are the things which are irreversible or which are sensitive, risky, which human should take care of. And based on that, I should design the agent. And what success metrics define completion? So that is the idea. So if you cannot answer these questions, you are not ready to implement an AI agent. So while you're implementing an AI agent, you have to answer all these questions. And if you have answered to all these questions, whatever AI agent you will be designing, it will be reliable, it will be scalable, and you can keep on evolving it. You can keep on adding more and more features to it. So that's the idea. So finally, we completed this lecture. So in this lecture, we saw that how to map real world workflows into agent actions, the importance of separating structured and unstructured input, how to translate business APIs into agent tools, why scope boundaries are critical, when to keep problems narrow, why over automation is dangerous, the shift from chatbot to decision plus execution system. So basically, this lecture, it gave you the core design method. Like it gave you an idea that, okay, if I want to design an agent, what things I should consider, what design principles I should keep in mind. Because this module is about designing agents, and this lecture will give you a mindset, so some principles you should keep in mind while designing agents. I hope you got a very good understanding of the concepts that we covered in this lecture. So do subscribe to our YouTube channel, ScaleUp University, for more such interesting concepts and lectures, and also the courses. Thanks for watching. Thanks for your time.